So this is a continuation of 11.6, which is absolute convergence ratio and root test. So this is the last part of the part of concept video on 11.6. So we have already seen the definition of conditional convergence, and also we saw um, how to apply ratio test. And now we are going to define how to apply the root test, and we will do an example of root test. So what is root test? If limit is n approaching infinity, nth root of uh, absolute of a sub n equal to L and L is less than 1, then the series sigma an is absolutely convergent. As absolute convergence implies convergence, so it is also convergent. 2. If limit is n approaching infinity, nth root of absolute an is L, and if that limit L is more than 1, or the limit is equal to infinity, then the series sigma an is divergent. 3. If limit is n approaching infinity, nth root of absolute an equal to 1, then the ratio test is inconclusive. So which means that you cannot say anything about the convergence or divergence of that given series. Here, one thing to note, if limit of the nth root of absolute an, you start to apply the root test and you come up with the third condition, which is inconclusive condition. Then part 3 of the root test says that the test gives no information. The series sigma an could converge or diverge. If L equal to 1 is found out from the ratio test, don't try the root test, and because L will again be 1. And if L equal to 1 in the root test, don't try the ratio test because it will fail too. So now example 6, what it means. Example 6, test the convergence of the series sigma n varying from 1 through infinity 2n plus 3 over 3n plus 2 whole thing to the power n. So we will apply the root test here because the indication to apply root test is that the exponent should be n. The whole thing to the exponent should be n. So when you take the nth root, that n and nth root will, the power n and the nth root will cancel out. So that's the idea of the root test. So without the sigma, you can find out the an. You can write down an. So first we are going to apply root test. So by looking at the expressions, given problem, you should be able to kind of guess which test you want to apply. Here, because of the exponent n, it suggested that you apply the root test. So an is without the sigma, the given expression, 2n plus 3 over 3n plus 2 to the power n. Then you are going to take the nth root of absolute an. So here it looks everything positive. So absolute really doesn't make any difference in this problem, absolute sign. So it is 2n plus 3 divided by 3n plus 2 to the power of n. So nth root and nth power, they get cancelled out. So you get 2n plus 3 over 3n plus 2. Now we are going to apply the limit as n approaching infinity of nth root of absolute an. So that is what we have to check here, whether it is less than 1, the limit is less than 1 or more than 1 or equal to 1. So we are going to apply the limit. So limit n approaching infinity of 2n plus 3 over 3n plus 2. So anytime you have infinity over infinity, you will divide by the highest exponent. So divide highest exponent of the denominator. So you get 2 limit as n approaching infinity. 2n over n, which will be 2 plus 3 over n divided by 3n over n, which is 3 plus 2 over n. We notice that this is 0. Also this one is 0. So we are left with 2 over 3. So this quantity is less than 1. Therefore, the conclusion would be by root test, the given series which is 2n plus 3 over 3n plus 2 to the power n is convergent. In fact, it's absolutely convergent and hence convergent. So you can also say is absolutely convergent and hence convergent. In this case, this particular problem, it does not matter too much because all the terms are positive. So absolute convergent would automatically means convergent. We were absolutely convergent and hence convergent. So in this suggested problems here below, in my videos, I have shown for the section videos. In the section videos, I have shown the problems. Problem number 3, problem number 10, problem number 13, and 31. All these problems are done in the section videos. Please refer to section video 7-6 for these problems, number 3, 13, 10, and 31. Hope these videos help.